So the major concept that we learned which helped all of us solve those problems was backtracking. Okay, and if you guys remember it well, there was just one major important concept behind backtracking, and that major concept was of that you do something, then you recurse or make a function call, and then you undo whatever you had done. Okay, now the most important thing is that correct, the most important thing is that your undo should be very consistent with your do. Okay, so if you swap, you have to unswap. If you left rotate, you have to right rotate, and so on. So today we will be seeing more questions based on the same concept of backtracking, where you will see that the same thing will keep on being applied in different flavors. Okay, and let me tell you, this is the most important thing. I mean, if you become very comfortable with this, then you will be very comfortable dealing with DP as well as graphs, okay, which are considered the most advanced topics in DS algo. Okay, so I'll rewind all of you back to the first problem that we had discussed while talking about different combinations, which simply said that you will be given an input array, and that is like a set. Okay, all the elements are distinct, and I wish to generate all the combinations. Okay, so in the solution that I had spoken about this, I had taken a temporary array and I had a count variable which was telling me that, hey, these many elements or these many indices have been filled by you, and the next index to be filled by you will be count. Okay, and so tell me one thing, was the concept of backtracking involved over there? It was clearly not involved over there. It was not, right? Because there was no do undo kind of thing happening. Okay, I was definitely doing recursive calls, but there was no instance of doing something and then undoing that thing, right? Okay, some of you had questioned me that day that why not use a vector, and now I would like to talk about it. So can I use, instead of using a temporary array, can I prefer to use a temporary vector? Okay, I can do it. Now when I use this temporary vector, then you can either, manipulate this vector as if it were an array. You can very easily do that, because in vector, array type of operations are also supported. You can do temp of I equals to 9, something like this. Okay, to place a value at ith slot in this vector. But another way to push an element in the vector is something like this, where you do temp dot pushback 9. What is the difference between this and this? The difference is, here you are explicitly stating that, hey, the new element, I want that new element should come at ith position. But in the second case, you don't have any choice. In the second case, the new element will always come at the last position, which is the end of the vector. So this is the difference between these two things. Okay, now tell me one more thing. While you are using a temporary vector to get your job done, and let's say insertions are being performed in this manner, there do you need a size variable to keep track of the size of your vector? You do not need that. And why you do not need that? What is the reason behind that? Because vectors already provide a size method. So when you do this thing, then you will automatically get to know the size of that vector, right? So that extra variable is not at all required over here. So let us just try to use a vector, and then let us see how things are going to happen. Okay, so this is my set that I have. Okay, so I'll start my journey with first element whose index is 0. Okay, and I'll start with an empty vector which doesn't contain anything. Okay, so let us do it piece by piece. So initially I am at index 0, the element here is 1. How many choices do I have for that element? The elements are all distinct, so how many choices do I have? I have 2 choices. Either I can include it or exclude it. So if I include it, what will you do? You will say that, hey, you want to push this thing in your vector, and for push you are going to use this thing. Okay, so if you push this thing in your vector will start containing 1, and then you will move on to next index, which is index number 1. Okay, so this was your yes branch. In no branch, you would want that 1 is not there in my vector. You want that 1 is not there in my vector, and you move on to the next index, which is index number 1. Now this vector, would you want to pass it by reference, or would you want to pass it by value? So either of the ways are okay, but passing by value has got a problem. Passing by value has got a problem that let's say you have made this call first, so this vector will get polluted and a lot of things would be present in the vector by the time you come over here. Okay, so you want that for this thing to begin, the vector should be empty, right? So how to achieve that? One way is to ensure that you create 2 new vectors and then get your job done. Another way is to, as one of you said, another way is to undo whatever you had done. Okay, let us understand more about it. Okay, see, this function was responsible for performing a push. Okay, this was the guy which was responsible for performing push. After performing push, it made a call over here. Now one thing is being guaranteed, that all the subsets that I am going to get from this tree will definitely contain 1 in them. Okay, and all the subsets in this tree will definitely not contain 1 in them. Okay, so it is my responsibility to ensure that before invoking this call, I pop the thing that I had pushed into the vector. Okay, so what should I actually do? First, I should push the element into my vector. Okay, and then I should make this call. Now when this call is over, what does that mean? That means that all the subsets that would start with 1 would have got printed. Then I need to perform a pop, and after performing that pop, I need to make a call for the second part. So this is how you can use the concept of backtracking over here, and with just 1 vector you can ensure that all the subsets have been printed out. Okay, so I am going to draw the tree corresponding to it. You have to understand it very carefully. Guys, you cannot live without understanding this concept, let me tell you that. If you don't understand it very clearly, then that will be a very terrible scenario to be in. So initially I had an empty vector. I was at index 0. So my first choice was a yes transition, where I pushed this element into my vector and then I moved on to 1. Okay, I'll come back to this later. No. Okay, now again here I am at index 1. So at index 1 I have got 2. Again I have got 2 choices. Either I can take it or I can not take it. So if I take it in my vector, I'll end up getting 1 and 2. And whenever I am taking it, then I am pushing it. So push automatically brings this 2 after this one. Okay, so now you will move on to next index, which is 2. Now index 2 is this. Again 2 choices are there, yes or no. So corresponding to yes, you would want to take this element in. So automatically 3 would get pushed after 2, and now you are at index 3. Okay, what should this be? Should this be your termination condition? Yes, this should be your termination condition, because now your index I has become equal to n, where what is the n? N is equal to the size of this array. So you will print this out. Okay, now corresponding to this no transition, what is it that you would want to print? You would simply want to print 1, 2. And how can you do that? You can do that by undoing whatever you had done. So what you had done? You had performed a push. Okay, so push is okay. After that, recursing is okay. Now you have printed all the subsets that contain 3 in them. But now you want to print all the subsets that strictly do not contain 3 in them. So you need to pop whatever you had pushed. So when you pop, then what will happen? That after popping, so basically once you have printed it out, then the control will go back to this function. Then this function will perform a pop. Performing pop means this will become like this. And now you can make this no call, corresponding to which your vector is looking like this now. And now again this is your termination condition, where you end up printing 1 and 2, right? Now again, when this is your termination condition, the control will come back to this. This is also completely over, so now the control will come back to this. Okay, so what should happen here? Tell me, before making a no call, what is it that is supposed to be done over here? Firstly, pop, right? Why pop? Because this was the function that had performed a push. And push of what? It had performed a push of 2. Okay, so now it has printed all the subsets that contain 2 in them. So now it should first pop whatever it had pushed. So when the pop gets called, so this 1, 2 will transform to 1. And now this no transition will make a call for this, and so this is the way it will keep on moving on and on and on, and then you would end up printing all the subsets by just having to use a single vector, passing that vector by reference and performing backtracking. So you can use vector also to get this job done, and this is the really simple and classical backtracking that can be used over here. So if let's say I have to write the code of this, so I simply want to print all the subsets. I can keep it void. Okay, tell me what all are the things that I should pass. So first thing I should pass should be the index. Index corresponds to the index of input array, not the vector. Okay, and what should be the second thing? It should be my vector, and that vector should be passed by reference. So I need to pass these things. Yeah, now tell me, how do I go ahead? So first there will be a termination condition. In termination condition, what do I have to do? I simply have to print the contents of my vector and then return. Okay, so if I see that I has become equals to n, that means I will print my vector. Can you print your vector? Yes, because you know the size. By vec.size, you know the size of vector, so you can easily print the contents out. So first thing you will do is to print the vector, and after this you would simply want to return. Otherwise, what would you want to do? Otherwise, you have got a yes transition and you have got a no transition. Corresponding to yes transition, what is the first thing that you do? First thing that you do is push. After pushing, you make the function call. When this function call is over, then before making no transition, you want to undo what you had done. Okay, so pop and then like this. So the first line of code that you need to write should be to push. So you will say vector dot push back what? This element, which is a of I. Okay, what will be next line of code after pushing it? Next line of code will be to recurse, okay, which is the function call for yes transition. So now when you make function call for yes transition, you pass this vector by reference and you move on to next index. Now once this is over, what will be the next thing that you are supposed to do? Before making no call, you are supposed to pop what you had pushed. So how can you pop? You can simply call vector dot pop, right? And after this you can call that no transition. So that's it. So this is how you can easily get your job done, and you can simply print out everything. Again, you see, like just for your ease of understanding, I am saying basically what is happening is that in any recursion tree, the control transfer is from top till bottom, but return happens from bottom till top. So you are actually wanting that whatever was the bottommost function, okay, that should perform its pop before it performs its pop, because it's obvious that the number of subsets that start with 1 will be more in number than the number of subsets that have 1, 2 in them and then have 3 or have nulls or whatsoever, right? So considering this particular thing, we have to ensure that when you are over here, then you make a call for push, and then you recurse, and then you perform a pop, and this pop will happen when this entire thing is over. So basically what happens, that the pop of last level will happen first, and then the level above it, and then the level above it. And how does this pop ensure that the element that it had pushed, that is only being popped out? How? Because whenever you push it, the element gets pushed to the end of vector, and whenever you pop, the elements gets popped from the end of the vector. Okay, so the only point that I'm trying to make over here is that you should not be very, very blind and you should write do undo like just anything. Be very clear that whatever you are undoing, is that undoing what you had done or is that undoing something else? Okay, so you have to be very clear about that. Did you get my point? This was a very simple example, but you should be very careful while playing around with this thing. Okay, if I would have wanted, I would have changed this order also. By changing the order, I mean first I would have called for no and then I would have called for yes. Would I have done something like this or not? I would have done. And so nothing changes. The only thing that changes is that this line of code would have come first, and after this coming, I think everything else would have remained as they are. You push, you call, but after calling, you must pop it out.